In this presentation, we are going to discuss what is science. When we say the word science, many images come to our mind. For example, we can think about the models like the atomic model or like the DNA model, also in chemical structures, in formulas. But are all these things science? The answer is no. These are just tools of science. Then what is science? Then science is basically a method that we can use to study a set of information. Any subject that uses the scientific method to study a set of information is a science. And one example, some example of sciences are the physics, chemistry, biology, and geology, because all these subjects use the scientific method to study some information. The general scientific activities are: first is collecting observations, then developing explanation for those observations, and finally we want to test that explanations. How we can do that? Then we can do these different activities in science using the scientific method. Then the scientific method, we need to follow some steps, and these steps will be followed when we are doing our experiments. The first thing we had to do is to make the observations, and that observation requires some explanation. Then we propose some possible explanation to those observations, and this we call the hypothesis. Then we need to determine what kind of technique we want to collect to try to test that hypothesis. Usually we design an experiment we will use to test that hypothesis. The next step is conduct the experiment or use the technique we are going to we decide to in order to test the hypothesis. Then we will have the results, and these results will tell us if the test support the hypothesis. Then if the test supports the hypothesis, then we can accept that hypothesis and trying to give the formal explanation to what we observe. But what happens if the test doesn't support the hypothesis? Then in this case we need to reject the hypothesis, and there is two possible steps after that. First, we can propose a new hypothesis, or we can use a different technique. We can design a different experiment to try to test our hypothesis. Then all of these are the steps we need to apply when we use the scientific method. Explanation and investigation always come together. Then the explanations are related to the hypothesis, and investigations we can correlate with the experiment. Then remember, the hypothesis is the tentative explanation for some observation, but the experiment is the recreation of an event to test that hypothesis. But it was not always like that. The early investigators in science were natural philosophers, and in most of the cases their explanations came from reasoning with no experimental evidence. But later, a scientific investigation provides evidence using the scientific method. This evidence, based on this evidence, then it is possible to support or reject ideas and concepts. As we said before, theory and experiments, they always come together and they will complement each other. And in science is important when there is a discrepancy between theory and experiment. When that happens, then the scientists must be need to formulate a new theory, or they need to modify the theory, or need to formulate a general theory in order to remove that discrepancy. One of the examples is the Newtonian mechanics theory, which can explain the motion of the objects when the speed is slow compared to the speed of the light. But what happens is this theory cannot explain the motion of the objects if the velocity is close to the speed of the light, which is 3⁻⁸ meters per second. Then 100 years later, Albert Einstein he formulated a new theory, which was the general theory of relativity, which can explain the motion of the objects when they move at a speed close to the speed of the light. And this is one example how the discrepancy between theory and experiment can help to the scientists to improve the understanding of fundamental laws. And this allowed also to have now numerous technological advances. One of these are the planetary explorations, high-speed computers, device miniaturization, nanotechnology, and sophisticated imaging techniques which are used in medicine. This is few examples how the relation between theory and experiment can help to the scientists to improve the understanding of the nature. The atomic model is also one of the examples how the experiments and theory are important in science. And here we had the timeline of the atomic model, and we can see how the atomic model was changed through the time. And this happened because it was needed to explain the experimental results that were found at that time. Then in order to explain the new experimental evidence, it was needed to change the model. The model used to explain the atom. And this is why here we can see how this was changed through the time. This mainly happened in the last 200 years. Another important concept that we need to understand in science is the concept of laws or principles. Then basically any law or principle explains what happens. A law is a mathematical relationship that is consistently found to be true. It can be expressed as a statement, an equation, or graph, and explains some specific phenomena, and I will say is always true and is not subject of any revision or replacement. One of these examples is the Charles law, and we say the Charles law explains what is the relation between the volume and temperature at constant pressure. Yes. Then the relation between volume and temperature for any gas at constant pressure is direct proportional. Then we can express that relationship that is always true is just using a statement or a graph. In this case, yes, we are using a graph. But also we can express a law using equation, and this is the case of the gravitational law. Then This equation expresses the gravitational law. Say the force, the gravitational force, is direct proportional to the product of the masses, but is inversely proportional to the distance between these two masses. Then we can express the gravitational law using an equation. And one more example is the second Newton law, or the motion law, which can be expressed using an equation: force equal mass times acceleration. Then this is another example. We can express the law by an equation. One more concept we need to consider in science is the concept of theory. Basically, a theory explains why something happened. Then the theory is a general principle, is a set of principles that has been developed to explain a wide variety of phenomena. The theory is based on laws, principles, and hypotheses. And there is considerable experimental support, as that the theory needs considerable experimental support. The theory must be tested in many ways, is complex because explain that phenomena in detail, and also the theories are subject to revision, and depend on the experimental evidence. The theory can be changed, can be replaced, or can be or sometimes is needed to reformulate a more general theory. One of the examples of theory, and we already explained, is the atomic theory. In that case, because of the experimental results, it was needed to change the atomic model through the time. One more is the theory of evolution, and now because of the evolution of the genetic, then now they combine with the theory of evolution and genetic, they combine, and there is more general theory which is called neo-Darwinism. Two more examples which explain a wide variety of phenomena is the cell theory and the theory of relativity. One more thing is used in science to represent phenomena that we cannot see directly, yes, because they are very small or they are really big. There are some phenomena, there are some things that we cannot see directly. Then we use model to understand better that kind of phenomena. Then, for example, if we saw this model, we know this represents DNA. This is really a small structure, but if we had the model, then we can understand the structure easily, even if we cannot see that. Then if we had this model, we know this corresponds to the Earth, and the Earth is big, as we cannot see the complete Earth. But if we had this model, is easier to understand. Yes. One more thing is the atomic model. Then is we cannot see the atom, yes, but using the model we can imagine, yes, all the subparticles of the atom. And this is the solar system, which is big, but using this model we can understand better what is the solar system. Another thing is we need to consider is the pseudoscience. The pseudoscience includes beliefs, theories, or practices that have been or are considered scientific, but they are not based on the scientific facts, means they are not based in the scientific methods. And one of these is the astrology. Yes, the astrology looks like it's based in the is based on the scientific method, but it's not. And this is why astrology is not considered as a science. But another thing we need to consider as pseudoscience is related to the ethics in science. Yes, sometimes because of different reasons, then the scientific, some of the scientifics, they report things that are not true. Yes, that are not true. Then we can consider this practice as pseudoscience. Then in science, always we can verify the results. Everything is published in science must be peer reviewed, and it can change in science. The results can change if we had new evidence. But what happened in pseudoscience, the results cannot repeatable, are not peer reviewed, and usually is fixed ideas. One of the examples I can mention as a pseudoscience is recently publications in one of the most important British medical journal, which is called Lancet. In this journal, it was published that the treatment of COVID-19 with the drugs chloroquine and hydroxychloroquine raised the heart-related death risk for COVID-19 patients in the hospital without showing any benefit. Then what happened is they published this investigation, the results of this investigation, and when another researchers start asking questions about their results, they was not able to answer that questions. Yes. And the reason was all the data they used was manipulated. Then what the journal did, they withdraw the paper. This is one example in which in which we can see the pseudoscience. Then, in order to avoid the pseudoscience, then always whatever we publish in science must be in peer-reviewed journal. This must be reviewed by scientific peers, but we can see in the previous example sometimes it doesn't work. And also there are scientific institutions and organizations that lead the science. One of these I mentioned here is NASA, the DOE, which is the Department of Energy. NSF is the National Science Foundation, and also the National Institute of Health. This is all I had to discuss about what is science.